In this video, I'm going to show you how you can build a RAG or Retrieval Augmented Generation enabled workflow that allows an AI agent to answer user questions based on a knowledge base that you provide specific to your case. I'll show you how RAG works, how the workflow works, and we'll build the entire workflow step by step so you can understand how it works and how to personalize it for your needs. Okay, so let's go. All right, so let me show you how this works in practice. Now here I am in my N8N instance. And by the way, if you don't have an N8N instance that you can work with, just go to n8n.io and sign up for a free trial there. They give you like 2 weeks, I think, and then you can try it out. If you want to actually install it for yourself, I have a video on self-hosting for N8N, so check that out. But here is the workflow. So let me show you how this works in practice, and then we'll go into what it does behind the scenes and then how we can build it ourselves. So here we have two sections, right? We have the section for the input, where we actually provide the information to the system about what our particular system needs to answer. And then down below, we have the actual RAG system where we interact with the user and then answer their questions based on the documents that we provided. And behind the scenes, we have a Supabase account with a project with a documents table in our vector store that is empty at the moment. So let me show you how this works. We have at the top, we have a vector store input. We have a form submission where we can provide the document in the form of a, let's say, PDF or text document or whatever it is. And then we have a Supabase vector store where we actually send the information to our vector store through the data loader, through our data loader. All right, so let's execute the workflow and we get this pop-up that comes from this on form submission node. Okay, so here I need to select my file. Now, I have already downloaded this menu file from a restaurant in, I think it says Zanzibar here. So shout out to them. If you're in Zanzibar, check out this restaurant. But I've just downloaded their menu as an example of some information that we can provide to our vector store so that the system can answer domain-specific questions. So for example, here, if I ask how much is a hot dog, it won't give me a generic answer. It will give me the exact price for the hot dog here in the menu. So here, let me just select my file. Okay, I have menu.pdf and then click submit. If I go back to my system, then I can see that it ran through the whole procedure. It uploaded information to the vector store. So if I go back to Supabase project and I search the vector store, you can see that we have 5 chunks of information in this documents table. Okay, and we'll explain in a bit how that works. But now let me just go and interact with the second system. And here I interact with it through the chat system. So let me open chat, and here I can say how much is a hot dog. All right, so you can see that it accessed the Supabase vector with the embeddings API, and the result is it gave me the price for a hot dog at the restaurant is $7, which is the correct price here, right? So very, very specific, very good retrieval information for the data that we're actually interested in. And of course, you can provide any information you like. So if you have, for instance, documentation for your company, or you have some specific knowledge for your website or whatever it is, you can provide that as well. All right, so we have that in place. Now let me go through a little bit of theory on how we're doing what we're doing here. All right, so I'm in an Excalibur drawing here, so I want to show you how this works. Now, without RAG, how would we achieve this? We have a text or PDF document or whatever it is, and we want to answer questions based on that file. So what we would do is we would provide the entire document to the system, to the agent, and the agent will answer questions based on that. The problem with this is that if we have a large document, so let's say company information or documentation or internal data, or let's say a large novel or something like that, that can use up the tokens really, really fast and have the system cost way too much. So here, for example, we have the minuses, our token use and context window. Depending on how large your document is, you might exceed the context window, even though at the moment, I think context windows are in the millions of tokens. So that's less of a problem now, but still, depending on the size of your documentation or information, then it's a problem. And then, of course, the money. That is a big problem. You don't want it to cost your system to cost too much. You want them to be efficient. So that is without RAG, but how will we do it with RAG? So we have the two systems that I showed you earlier. So the first one is putting information into the vector store. So we have that text, PDF, whatever it is. And what we do with it is we split it into equal sized chunks based on a certain number of characters. So this is very, very basic. We just split the document into chunks. And then what we do is we use an embeddings model, which is again an LLM that converts those chunks into a vector store based on the meaning of those chunks. So how it does that is it goes to the foundations of LLMs, transforming words or tokens into multidimensional vectors. That is what LLMs do. So we pass it through an LLM and get that vector configuration for each chunk. So here we have multiple embeddings models. We have OpenAI, Hugging Face, Cohere, and so on. I just gave you a few examples. We're going to use OpenAI as we usually do. And then we store that in a vector store. Okay, so that is going to be Supabase for our case, but you have others. You have PG Vector. This is Postgres Vector, which you can host yourself on your local machine or on your VPS or whatever it is. You have Pinecone, Redis Vector, and so on. And then when we want to retrieve that information, what we do is we have the user make a request to the bot. The bot goes to the vector store to request information that is semantically closest to that question that the user has posed. Then the vector store returns a number of chunks. Usually it's like 4, but you can personalize that to return more, to give you more context to work with. And then from those chunks, instead of passing the entire structure, entire documentation to the bot, we just pass these most representative chunks back to the bot, and the bot can answer based on those. And then it gives us the answer back. So very, very simple, very easy to implement. All right, so let's go into our N8N and actually start to implement it. But before we implement it in N8N, we need a Supabase account. So if you already have that, go ahead and log into that and create a new project. If you don't already have it, then you can go to supabase.com, create an account. Once you create the account, you will be asked to create an organization. And then from the organization, you'll be asked to create a project. So go ahead and create a project, very simple, very basic, leave all the options by default. So you can see I have my organization here. You can see that I have a few projects here. I'm still on the free tier, so you can use that as well. And I have a new project. So you should have a window similar to this to create a new project. So I'm going to call my project something like RAG tutorial, and I'm going to set a password for the database. Now this is going to be important. You need to actually remember this because we will use it later in N8N to actually connect to this project. All right, so once that's done, go ahead and create a new project, and that will take a bit of time to actually set everything up. Now, while we're waiting for this, let's go back to N8N and start to implement our workflow. So let's add a first step, and that's gonna be an on-form submission. And here for the form title, we're gonna say submit file. The description we don't need, add a form element, and the field name is going to be file, and the element type is also going to be file, and that's pretty much all we need. We don't need multiple files, and we don't need to set the required type. Okay, so we have the form submission. Then let's click on the plus here. I'm going to search for Supabase vector store, and then we're going to have add elements to the vector store. First of all, we need credentials. Now, I already have some credentials, but of course, you're going to want to create new ones. So let's go through the process together. Now, we're going to need host and service role secret, and we can get that from Supabase, of course, assuming that your project has finished building. Let's go to our project settings. And here under data API, you're going to have your project URL. So let's copy that and paste it in the host. For the secret, we're going to need to create an API key. So let's go to API keys, not the legacy API keys, but the API keys tab here. And we're going to create new API keys, click create, and then that created the default key. Let's go ahead and copy the key and paste it here under service role secret. All right, so now let's go ahead and save. That tested the connection and it tested successfully, so that is fine. We also need the table name, but for that we need to run the previous node to actually get that information. So let's run this node for on form submission. That is giving me an issue here. Let me just deactivate this for a second because it doesn't have the table name. So it's kind of a chicken and egg issue. So we need to deactivate, run this, and then we can have the Supabase vector store. So let's run this. Here I'm going to select my file. All right, and then click submit. That is fine. Let me just close that, activate the vector store, and now we have the information here. And then for table name, we don't actually have a table yet. So in order to actually get a table from Supabase, we need to create our table, but we can't just create it ourselves. In fact, N8N provides a script to create that for us. So let's click on the docs up here. And then if we scroll down a bit, we have Supabase provides a quick start for setting up your vector store. Click on that, and we have the script here. Let's copy the script, go to Supabase, and here we have the SQL editor, new snippet, paste that in, and then run it. All right, success, no rows returned, so that should be fine. Let's go to database. Where is that? Let's go to table editor, and then we have our documents that was created for us. So now we have our table here. Let's go back to N8N, and here, let me just save and refresh. And then going back here, we should see documents. Okay, so that is automatic because it connected to the vector store with the credentials that we have created. Okay, so we have documents here. Okay, so that's all good. Now we have embeddings, and we're going to use embeddings OpenAI. Of course, you need an OpenAI account. If you don't have that, go to platform.openai.com and create an account there. Obviously, when you're working with AI and automation, you're going to need an OpenAI account for whatever you're doing. All right, so now in addition to the embeddings, we need a document loader. So now let's click on that, and we have the default data loader. We're going to choose binary instead of JSON, and that's pretty much all we need for the data loader. Okay, so with that, let's go ahead and run or save first, and then execute our workflow and see if we get some information in the data store. All right, so I've selected my file, menu.pdf, and then click submit. The form was submitted, and this worked correctly. So now if I go here and refresh, I should see a lot of information here. And you can, of course, personalize this a little bit with your embeddings model here. So you can add options for the dimension, the batch size, and so on if you want to personalize this. If you want to play around with, if you have a large data set you need to play around with and see what gives you the best performance, let's say. But in any case, we have the functionality in place that adds the information to our vector store. So now we can go ahead and create the actual workflow to interact with that data. So let's add a chat trigger. Okay, so that's pretty much all we need here. Then after that, we're going to have an AI agent. And here we have connected to chat trigger node. That's basically all we need. Let's add a chat model. Down below, we have OpenAI chat model. You can select from the list for 1 mini, whatever it is. I'm going to leave this as it is because it's a bit faster, so it runs a bit quicker. But in a real world situation, a production environment, you might want to choose a smarter model. Also, let's add a tool for Supabase vector store. And here, of course, we need to connect with the credentials, and we're going to choose documents for the table name. Okay, for the description, we're going to say use this to get information on the restaurant menu. This is useful for the AI agent to know what this vector store is about. So you need to give some description of the data that you have there. And then, of course, you can set the limit of how many chunks you're going to retrieve from the data store. This is set at 4 at the moment, but you can increase or decrease that and play around with that value to see which one gives you the best performance. Okay, so that's pretty much it. We need an embeddings model. And of course, we're going to use the OpenAI with the OpenAI credentials and text embedding 3 small. The same one, importantly, the same model that we've used here. Okay, so this is also text embedding 3 small. So this is actually important. Okay, so we have, are these connected? Yes, they are. Okay, so we have our system in place. Our AI agent needs to be personalized a little bit. So for example, let's just go ahead and run maybe just provide a message just to have some information here in the input node. So to personalize our AI agent, you can see that it automatically found JSON.chat input, which is the message that the user sent, so that's good. But I will also want to have a system message here. Instead of "you are a helpful assistant," I want to say something like, "For a restaurant business, for every request, check the menu in your vector store and respond with accurate information about current pricing." Okay, so that we give our agent some information about what we're expecting from it. All right, so that is all we need. So let's say we want to ask something about our menu. So let's say something like chicken pili pili, whatever that is. How much is the chicken pili pili? And then the answer should come quickly. It should be $10. There it is priced at $10. So this is how the system works. Basically, we have an input for our vector store, and then the agent can access that vector store to retrieve some information. And of course, you can add a lot more functionality here. You can add, for example, you can embed this in a website or a chatbot or whatever it is. By the way, if you want to download this entire workflow, you can find it on my community over at school.com/bottribe. The link is down in the description. And also, if you want a tutorial on how you can embed this model or a workflow into a chatbot on a website, check out the next video. You will find the information there on how to do that step by step, as I always do for my tutorials. But in any case, thank you for watching, and I will see you in the next video.